Hello everyone, so I'm back with another medium question. In this question, we are given a root of a binary tree with n nodes, where each node in the tree has node.val coins, and there are n coins total throughout the whole keys. In one move, we may choose two adjacent nodes such as from parent to child and from child to parent, and we can transfer one coin between them. We need to return the minimum number of moves required to make every node to have exactly one coin. So we have this tree that has 6 nodes, so our n here is 6, and so the total number of coins in the trees should be 6. So let's say there can be 3 here and 3 here, so total would be 6. Or you can have something like 4, 1 and 1. That would also be a valid input for this question. And what we have to do is we have to convert this tree into a tree where every node has one coin. And each node can have one coin because the total number of coins are equal to the number of nodes. And how can we do that is by performing some steps. So if this node contains 4 and this node contains 2, and we need to move coins in such a way that we can go from, for example, from this 4 to its parent and its child, and both will be counted as one step. So in the first step, what we can do is for 4 here, let's say we make it to 3 and transfer one coin here. So let me mark it for you so we don't forget the steps. So our step counter step was 0, now it became 1. And now we will move one coin again from here to the root. So that will be our second step. So step now becomes 2. And now this is 2. And for this node, we require one coin. So let's say we take it from here. So our step now becomes 3. Now we have taken 3 steps. And now for this coin, we need 1. And where is that 1? It can come from here only. So we'll make it 1, transfer one coin to this node. This will become 2 temporarily. Then it will become 1 and transfer one coin to this. And then it will become 1. And then finally we have reached here. So how many steps have we taken? 1, 2 and 3. So 3 steps would be added and 3 plus 3 would be 6. So we required 6 steps in this particular example to move the coins. If we look at this example, then we can move 2 coins from this node to this node, and which will require 2 steps because we can move 1 coin at each step. So 2 coins will be transferred and it will become 1. And then it requires only 1 coin, so it will become 1 and transfer 1 coin to this node. So now I will explain you the way I have solved this example using dryRun. So I have 2 functions. The first function is just a helper function, which tells me what are the number of nodes rooted at a node and what are the total number of coins in that subtree. So for example, the helper function for the whole tree now would return me 2 numbers. The first number would be the total number of nodes, which here is 6, and second will be the total number of coins. That would be 6. For root node, both will be equal because that's how the question is framed. And now if we see the left side of the root node, so our helper function over this will return us the number of nodes, that is 3, and total number of gold coins. And from right, it on helper function will return the total number of nodes 2 and gold coins, that is 4. So if we look at this result, what you can think is that here the nodes are 3 and the number of gold coins are 2. So this means that we require one coin for this whole subtree to be valid. Okay. And how are we going to do this is we can see the value of node and the value of right or left subtree from which we require the answer. And so in this example, we require one gold coin for this tree, and here we have 2 extra. Here we have 2 extra nodes, 2 extra gold coins. And so how can we solve it? It's based on recursion. So first, if we look at this 2, if we look at the root node, then we know that its left side is deficient and right side has more coins. And if right side has more coins, so how many more coins? It has 2 more coins. So we can take 2 coins from it. So we will take 2 coins from this node and update root value only. Because we have taken 2 coins, so let's subtract the coins here. So 1 minus 2 would now become minus 1. Minus 1 doesn't make any sense for now, but you will see why we are doing this. And as we have taken 2 coins from here, we will have 2 now here. And now we see the left child, it requires 1 coin. So this root node will update its value to 1 and increment this value to 3. And now this helper function would become it will become 2, 2, because -1 and 3 will sum up and give us 2. And while this 2 and 2, this will become 3 and 3, because 1 is transferred from here. So now we have handled the root node and we have successfully transferred these 2 coins from here. We have transferred these 2 coins because there were 2 coins extra, and so these 2 coins have been taken from here, and 1 is transferred here and 1 is taken by the root node because it was also 0. And now we have handled the root node and we need to just handle its subtrees. So if we are at this subtree and now this subtree, first let's go to left. So what's the left subtree has is that its left will return it 1, 0, and its right will also return at 1, 0. And both are deficient, and from our root node we can give them values because our root node is definitely 3. It has more gold coins. So it will give 1 coin to it and 1 coin to it. So it will become 1, 1. And that is the value would be increased by 1, 1. And it will become 1. We will look at the steps. We are just handling these things right now. And now let's move on to this node. It has -1 and it needs 1 coin. So how many coins are required? It requires 2 coins. So 2 coins it will take from its child because it has more gold coins than it requires, because this will return 1, 3, and it has 2 more childs. So 2 will be taken by it and 2 will add here, it will become 1, and we need to subtract here from 3, so that will become 1. Now all of these are 1, so we can somehow think of way using recursion to solve this, looking at the current node and the values returned by the helper function for its left and right child. And now the counting steps part is kind of really easy, because you know that we can try all of this again, but as it was seen that this was 0, so when we were at this node, we took this 2 from this node and added and made it -1. So we have taken 2 coins from the right subtree. So our steps would be now 2. And for the left subtree, as we see, we have transferred 1 coin to it. So again, it will be counted as a step. So it will become 3. And now this is done. Now we move on to here. And this has become 3 now. And from this 3, we transferred 1 coin here and 1 coin here. So our step will be increased by 2, 1 for this and 1 for this. So that will become 5. And now we will look at this node. And from this node, we have actually taken 2 coins from its children. So that would become 7 again. And that's nothing but the total number of steps or the minimum steps that you require to convert this tree into the desired tree. So if you have any doubt or you have a better approach to this problem, because it does exist as I saw the editorial, but this was something that I came up with my own. So I hope that you have understood this problem. If you have any doubt or any problem in understanding any part of this code, feel free to comment down.